Hello everyone, my name is Dr. John, and in this video we'll be going through TimeGPT, Tabula 8, and RDL bench. We'll be exploring these, and we have some few collabs for each of them. So, first five collabs will be going through TimeGPT and explore. Uh, so we have this multiple series collab where we are trying to forecast multiple series and using TimeGPT. And TimeGPT provides a robust solution for multiple series forecasting. So what we'll be doing is that although TimeGPT is a global model, it won't consider the inter-feature relationships within the target series. So and GPT does support the use of exogenous variables such as categorical variables like category, brand, numerical variables, example, temperature, prices, or even special holidays. So what we'll be doing is we'll start with import packages, and then in the next one, what we'll be doing is we'll load the data, and then we'll be plotting the graph, and then we'll be forecasting multiple series. So in this, we are forecasting multiple series, and followed by plotting the, we have the other available models in Azure AI, and if we are using Azure AI, we need to mention the model name Azure AI, and that is what we did earlier. And now we are using this, and we'll use the historical forecast. Where we are using that historical forecast, and add history will be setting to true, and you can compute prediction intervals for historical forecast adding this. And in this one, so let's go to the next one. We'll be doing a Bitcoin prediction one. We'll start with loading this collab, and then in this introduction, we have forecasting time series in our ubiquitous task in finance. And here we'll be loading Bitcoin price data, and the first decentralized. So Bitcoin is the first decentralized currency and is one of the most popular cryptocurrencies. The transactions are managed and recorded on a large ledger known as the blockchain. So we'll start with loading the data, which is the Bitcoin price data, and then we'll rename data, date, and DS. Like we'll rename date and close as DS and Y respectively. So we'll be predicting Y, and then we'll get started with time GPT. So I have changed the API value for security reason. You can go to a Nixtla and generate your API key. Then we'll try to visualize the data. So we see some trends in seasonality on this data. Then we'll use time GPT and forecast with time GPT. We will just call this function forecast with the data frame we have and the horizon we want. That is, we'll forecast the next 7 days, and we'll set level list, the confidence level for prediction intervals, and that's it. We're done. And we can plot the next 7 days. This is how it looks like, and this is how it was looking like, and this is how it looks like for the next 7 days. We'll plot that, and we will see uh, it will extend Bitcoin price analysis with time GPT and detect anomalies as well. So we can detect anomalies, and this is the graph for it, and understand the model's limitations. So it produce point forecast and quantify the uncertainty of your prediction, and it also detect anomalies. We'll go to the next one. we'll be fine tuning in this one, and fine tuning is powerful process for utilizing time duty for more effectively. And we'll start with importing the packages. We'll be using the air passenger CSV, which have timestamps and values. And in the next step, we'll be using fine tuning, and we'll fine tune steps equal to 10, which means the model will go through 10 iterations. Now we'll control the level of fine tuning by fine tune depth, and that's it for this one. And we'll go to the next one, which is anomaly detection. We'll try to detect an anomaly by detecting some abnormal points and that deviate from normal behavior in the general series. So we will again load the next line, and then we'll load this Maton Manning data, which tracks the visit of Wikipedia page of Maton Manning. So we definitely see some patterns over here. Plot that, and we'll detect try to detect the anomaly by just calling this detect anomalies function, and then good to go. So these are the anomalies that it has detected. These are the uh, anomalies 1199, and anomaly detection with exogenous feature is also available on TimeGPT. So let's explore that one as well. We'll modify confidence intervals, and this is how we can use this. So we modified the intervals by 70, and this is what we got. Next up we have is energy forecasting. What we'll be doing here is we'll be loading the data, the PGM in the zone data, and we have the unique ID, DS, which is a timestamp, and the Y variable, which we have to predict. Let's go and look how it looks like. So this is how it looks like when we plot the data. And what we trying to do is we're trying to predict the energy forecast, and we'll see what time GPT, what is the time GPT duration. So we got this, and then we'll try to merge the different data frames we have and use the left join for this, and then we'll install model forecast. And once we're done with this, we'll group by the unique ID and apply this lambda function. Uh, and we'll train on 999 epochs, and we get the evaluation matrix and the average matrix for it. Next up, we have is Tabula 8. We will start with uh, installing the all necessary libraries, and we'll get this ML Foundation data, RDFM. We'll clone this GitHub repository. We'll get the requirements.txt, and then we'll install this additional dependencies where we are uh, trying to get the table shift.get. And once we're done collecting all the data sets, then we're good to go. Then we'll use the inference for tabular A and B, and we'll be using the inference model. And here we'll be uh, loading the model and try to set up it, do a setup where we load the model and the tokenizer. Once we're done with that, we'll create our own data. So this is how it looks like. It has location, it has setting, it has temperature, humidity, wind speed, pressure. And this is the data frame, and this is the location where so this is our target example here. And now we're doing prediction with continuous targets. So we have predicted 0 greater than 850 is between 700 and 750. So this is what we got from this. Like, next up we have is Tabula on insurance data. We'll do the same, we'll install everything, and then we'll fit the model, and then we'll call this uh, model.sample. This is what we got. Next up we have is RDL well bench. We'll start with installing all the dependencies, and once we're done with that, let's check out the training table just to make sure it looks fine. I think it looks fine. This one, and then we'll go to dataset.getDB. We'll get the DB we need of the package. We'll get this package, and once we're done with that, we'll go to the next step where we make P key, foreign key, primary key graph. And once that is done, we're all good to go. We'll print the data. We can check the data. Our main graph object and data is a heterogeneous and temporal graph, which is not permanent with node types given by the table it originates from. So this is how it looks like. We can also check out the tensor frame for one of the table. This is how the tensor frame look like. We can just do data races.tf and it will show. This may be a little confusing at first, as in the graph ML, it is standard to associate the graph object data, a tensor, example data.x, but this is a little different. So we'll do that. And now we need our model. So we'll call this model, and then we got the fit. We also need standard train test loops, so we'll use that. And now we are ready to train the data. We'll train the data, and we get the best matrix, and these are the matrix. So thank you for this video. I hope you enjoy the video and learn something out of this.